Hello everyone, and thank you for joining us for the webinar today. My name is Alex Ulterides, or Alex G, and I will be presenting the 3DExperience bid-to-win solution for automotive suppliers. This solution is a complete integrated platform for managing specifications, requirements, projects, quality engineering, product engineering, business intelligence data, along with a number of advanced engineering functions, including analysis and manufacturing. This is a very exciting and rich solution as it has a lot of powerful capabilities, and in our brief time today, we will unfortunately be unable to cover everything. However, the point of this webinar will be to provide an introductory look at the solution with live demonstrations, or essentially a conversation starter, if you will. At Inceptor, we have an extensive partnership with Dassault as both a solutions partner and also only the gold certified education partner in North America. At Inceptor, we have over 25 years of CAD, CAM, FEA, and PLM experience with 19 locations across North America providing software, consulting services, training, support, as well as application development and automation services. So product development involves more than just the design organization. There are many stakeholders involved in the design and manufacturing distribution of a product. So many solutions in this arena are disconnected. Where each stakeholder has their own information or way of doing something that is only shared on demand, for example, when asked or during a meeting. And quite often the time by the time key information is shared, it's out of date. So how much time is wasted waiting for a simple answer, or does this lost time impact your project schedules? Have you ever been impacted by out-of-date information? In addition, manual data entry solutions such as spreadsheets are error-prone as they tend to lead to spelling mistakes or errors such as incorrect or inconsistent information. So what is the cost of a data entry error? Another question would be, how will you manage design collaboration if your organization wants to go global? How do you ensure those same processes and are used and applied across the global organization? How is that information shared as a collaborative effort? So what is the benefit of visualization of the product instead of just seeing a number on a spreadsheet? Think of the benefits for non-design organizations such as project management office or even supply chain organizations to see and visualize what they're working with. So this webinar is going to address this type of automotive supplier product development challenges. The bid-to-win business processes framework is made up of 10 key disciplines. So each discipline is illustrated in the slide along with the phase of the product development process that it's involved. But again, due to the time limitations, we're going to focus on the 5 disciplines circled here on the slide that have the greatest impact for the majority of automotive suppliers. Other advanced topics are available for a deeper dive if we want to pursue that later on. So let's review the data that's managed from the beginning to the end of the OEM to supplier product development relationship, such as what is the data being managed, who owns and contributes the data, what are the deliverables, how is the data governed and monitored, and how are changes managed, or who's involved. So we can see right from the beginning where the OEM provides the supplier a specification, requirements are tracked, projects are initiated, tasks are created, and there's deliverables to be managed, such as documents, as well as managing the CAD bill of material or even the engineering bill of material, and all the issues and the change management's involved before even looking at the sourcing aspects for standardized or sourced parts. So there's definitely a lot more involved when you think about the management of a product development project. And you have on top of it the overarching governance of the project, such as in management of the health with dashboards and managing the product performance. So for today, we're going to start by focusing on an OEM performing a layered process audit of an automotive supplier where we track the activities and the data involved from the beginning where we have a request for proposal or RFP to the actual proposal data delivery exchange of an automotive seat assembly being produced by the automotive supplier. So for the demonstration, we're going to do a little bit of role playing to illustrate the different steps in the product development process through the eyes of an OEM auditor visiting a supplier's site. So the supplier team consists of a product manager overseeing an entire product development team with the OEM and the automotive supplier. So the project manager, the product designers, sourcing managers are all stakeholders in the product development process and responsible for one or more deliverables of the OEM program. Each demonstration that we'll see will represent a different layer of the audit, and in this case, they'll be broken down one day at a time, starting from the specifications review and ending with a product enhancement review. So let's begin first with the first day of the audit, where we meet with the product manager for the specifications review. So let's begin with the first day of the audit, where we meet with the product manager for the specifications review. As the auditor, we'll ask, have you received our RFP from our latest vehicle project? As the product manager responding, yes, we've received an Office document and we've stored and locked it in our 3DExperience platform. So if needed, we can refer to it any time during the project simply by performing a quick search. So to begin with, I'm going to start off searching for a document, and we can see we have over 600 results. Now, as the owner, I can use these 6W tags, basically searching by who, what, where, when, how, to quickly locate that piece of information. So as Clara, the product manager, I can quickly access any documents that I'm responsible for. And by the same purpose, we can also do a search based on the collaboration policy, where we know this document is part of the document release process. And we now see that our 600 search results have now been reduced down to 14. So I can now quickly access the document that's specific to what we're managing. Again, the fact that the document's being managed on the platform, we now have a unique name. We can see who's the owner, when was the document managed, and as well, we can quickly access that RFP simply by clicking on an icon to then quickly access, download, and open the document. Taking a quick look at the RFP itself, we can see and confirm that this is in fact the document that we're looking for. And at the same time, we can take a quick look at what are the requirements? What are we looking for? What is the automotive OEM looking for? And if we scroll down, we can now see that as part of the request for proposal, we have a number of specifications that have been provided to us, including ergonomics, where we have text and also imagery to associate to those requirements. So going back to the original request, now since the RFP has been captured inside of our platform, we don't need to work directly inside of your document for the management of those requirements. So let's first provide you with an introduction to the platform. So what we're going to take a look here right now is we're going to see the dashboard of the platform that's been shared with the project team. So the dashboard itself is configurable and shareable, where we have a number of different tabs that we can provide with inside the tabs a series of different widgets, or essentially functions that we can access key pieces of information of the project. In the top right hand side, we can see the name of the user that's logged in, and as that user, we can also find out what are the different roles that have been assigned to that specific user, such as a classification manager, mechatronic systems designer, or requirements manager. We also, as part of this platform, making it flexible, have the ability to then add additional content. In this particular case, we could create additional tabs and dashboards and then share that information or that content with other users. The left-hand side of the screen provides us with the compass, which essentially breaks down the different roles or the different apps that are available to us based on different functions, such as collaborative, design, simulation, or intelligence apps. And within each one of these sectors, we can then see the different roles and the apps assigned to those specific roles. So I can see the role that I have available to me, and I can also see, as for example, a mechanical and shape designer, the different apps that I have accessible to me, such as drafting or mechanical part assembly and other sheet metal apps and so on. To help customize or configure our environment, personalize it may be a better term to use, we also have the ability to then configure and decide what are the key apps that are that's more relevant to what I do on my day-to-day activities, and I can then use and drag and drop these apps into my tabs as part of the dashboard to then quickly access the information that we need. So taking a look at the requirements a step further, again, going back to, since the fact that your RFQ or RFP has been captured on our platform, we don't have to work directly inside the document to manage those requirements. We actually have a separate app for managing that data. So having used an integrated solution with the platform, we can then extract, and we have extracted the key pieces of information from the original spec document that you sent us, and manage them as individual items and objects within the system. For example, if we want to access the different ergonomic requirements, that same text and the images have been extracted from the document and placed in the system as their own individual requirement documents that we can then open up and take a look at and investigate. Each one of those requirements being its own traceable object in the system and the platform with its own traceable capabilities and links to other pieces of information such as design or quality objects. So basically, based on what we've seen here, essentially all the information processes that are managed and are accessible to all the stakeholders, and they're all each stakeholder is connected and has visibility into the project, the data, the responsibilities, and it's all part of a common platform where we then can leverage all those resources and assets within an enterprise platform as as a business framework that can then help drive continuous and sustainable growth. So let's move on to the second of the audit, where we meet with the project manager for the project and quality review. So as a project manager, my question is, please detail where we're standing in our latest project and tell me more about this new issue discussed in our last project status meeting. So as a project manager, my response is, let's review our current project status, where we can take a look at and access different key indicators such as tasks and deliverables, identified issues and risks, as well as other summary assessments for resources, finance, and so on. So what we're going to take a look at now is on the same platform, we're going to look at the project and quality review tab that we've defined, where we have a full list of different projects, and we also have access inside of this list to inside of the dashboard to some of the viewables that we've taken a look at. So our project that we're working on right now is the ISD seat APQP, and this project was initiated as a standard template or from a standard template that we've defined that follows the APQP standard. The first thing that we have the ability to look at is a dashboard that provides us with a status schedule, a schedule status, telling us where we are, what are all the tasks, deliverables, critical tasks, and so on. And we also have access to another dashboard that provides us with the business status, such as the budget, what's the actual versus the planned costs and budget along the project, as well as issues and risks and their impacts or probability within the project itself. We can also pick the schedule tab, which is going to give us a more formal or standard interface that we're quite familiar with respect to project, key tasks in the project. And one thing that we can take a look at, or that we will notice, is in this environment we have the ability to associate deliverables, and these deliverables are actually objects that are managed on the platform, such as deliverables that are linked to a managed requirement or linked to a piece of CAD. And we can also get a quick and better view through a phase gate view of the different phases in the project, as well as different deliverables at each gate. For example, we can see once again at the end of the first gate, there's customer requirements and also different documents to be managed as part of the gate for that project. Going back to the schedule, we can quickly expand and access every single task for that schedule. And in addition, what we can even do is we can take a look at and we can assign different users and also allocate their activity to the project by changing the view to either an assignment or an allocation view. In the assignment view, we can see, once again, on the left-hand side, we'll be able to see the different tasks as part of the project. And across the top right, we can see the different users. And simply by just picking on the cell next to the task and across and then down from the user, we can quickly assign a user to a specific task. If we were to change to an allocation view, we can then change the percentage for those specific users. To take this a step further, to answer the question as to where we are with a specific issue on this project, the one that we talked about in our last meeting, what we can do is from the execution section, we have the access to assessments, issues, risks, routes, approvals, and so on. And in this particular case, we can see a list of a number of different issues that are open, but we can even use these quick and simple to use filter tools in this particular case to take a look at if any issues have been escalated. So in this particular case, I'm going to filter and display that we have 2 issues that have been escalated, and this one particular issue, this test case failure, is the one that we were talking about during our meeting last week. So all from starting in the project and navigating through the project to access the issues, we can now see what this issue is associated with and how we're going to process and progress from this specific issue. So we do notice that this issue has its own name, unique identifier, and it was reported against our project, and there's also a validation plan associated with it. We can also tell that this issue has been resolved or is being resolved by a change action, which upon selecting on that change action, we can then continue to delve into this rich information that's all linked together across multiple departments as part of our overall product development process. So looking at this change action, we now have additional information. If we go into the summary view, we can see that this change action is associated with a CAD model. Again, diving a little bit deeper to understand what are we looking at. So rather than looking at just a number on a spreadsheet, we now actually have this rich information that tells us who owns these different actions, what these objects are, but we also get a visible or a viewable result, and also shows us how they're linked together. This specific model, which looks like a slider rail for the seat slider, is linked to an automotive assembly and also the change action. And if we want to get a better view, we also have an embedded 3D viewer that we can then open up and take a look at this model for more detailed information. So now that we know what the part was involved, if we want to get more information, how did this feature fail, we can also access a series of quality functions through the failure mode tab or the failure mode menu, where we have a list of the different deliverables related to FMEA. One thing we can quickly take a look at here is one of the FMEA documents, which is once again its own entity that is managed within the system, has its own unique identifiers, creators, and additional details, what part it's related to, what project it's related to, and what teams, and even the association to a requirement. Why was the FMEA even initiated? Well, it's because it's related to something that is a requirement from you as the OEM. We can now, if we want, take a look at more details of the failure modes, where we have the ability to then expand and take a look at each one of these different failure modes, look at the function, the failure mode and effect, the different failure mode causes, as well as the actions. So all this information is all available to us, but as well as being available to us online, we can quickly generate a report right from the interface that can then be shared during a meeting as a handout. Or if it needs, it can be emailed, but the key thing being is the live, up-to-date information is always on the platform. If we want to see some additional objects or different failure mode objects, we also have some DVPRs that are essentially, we've got access to our design verification plan and report, as well as other control plans that again are associated back to this FMEA report and tied back to the original CAD model and the issue and the project. So we can quickly see here that, in a matter of a couple of clicks, we can drill down to what information is, important to us related to our project and any issues that might crop up and who all is involved as part of this overall process. So what we just took a look at were essentially, we saw project dashboards on a common platform that essentially ensures that all the stakeholders are connected with real-time visibility into the project. And these standardized project templates ensure that all global members follow a company standard. The deliverable-based project management also connects all project contributors and stakeholders to the requirements, the design, the quality, and the manufacturing deliverables. So let's move on to the next day of the audit, where we meet with the product engineer for the engineering capabilities review. So one of the questions that the auditor would have is, how do you handle all the design changes we send you along with other product development data? Taking on the role of the product engineer, my response is that my goal is to reply as fast as possible to the OEM RFP request, including any requested technologies along the way. What we do is we use 3D design to perform feasibility studies among other different design alternatives. So in our case of the seat structure, our goal is to reuse existing design IP from our own templates and adapt that geometry to fit to the OEM floor panel and seat trim outline, while still respecting all the other requirements outlined in the RFP. So our first step is we want to quickly take a look and evaluate the geometry or the data set that was provided to us from the OEM, and we navigate to our seat project, where we can now see that the OEM context consists of a CATIA CAT product. However, if we expand the data set, we'll also notice that other data has been provided to us as well. So we can see that, for example, SOLIDWORKS data has been also included. Now, in our case, the fact of the matter is that while some automotive suppliers might struggle with managing design data or designs containing multiple different types of CAD files, in the 3DExperience platform, we have the ability of managing multiple CAD file types, not only just the native CAD files. So taking a step further, a little bit more detailed look of what has been provided to us by the OEM, we can see that we have a version or iterative managed file currently at version 0 that's been provided to us at a certain time and is managed by a certain individual within our organization. And upon taking a look at the model in a little bit more detail, we can see that we have access to navigate and to review the entire CAD structure of this assembly prior to even opening up into our native CAD authoring application, in this case, CATIA V5. Here's another point where we can even see that we're managing OEM data that contains more than just CATIA V5 data. This also includes an NX steering assembly. So knowing what we have to work with from the OEM, our next objective is to reuse our existing design IP, or essentially our own design templates, to create and adapt a new seat design or new seat structure to adapt to the OEM request. So we have a separate folder container that we use to manage both electric and manual seat templates, whereas part of this request is the OEM is asking for an electric seat. So what we have is we're going to make a clone and reuse part of this entire seat template in order to use it as part of the feasibility study. So once again, we have the ability to navigate and take a look at the seat structure. In our case, what we would like to do is we'd like to make a copy of, or essentially again, clone the seat structure where we have the ability to quickly make these changes or quickly clone the data using a couple of different commands. So within the save as structure, we have the ability to see the entire structure of our assembly, and we know we want to replace essentially everything that contains the word generic with the name of the RFP. So with just a few steps here, we have the ability to then capture everything that includes underscore generic and replace those models and make a copy of that model with underscore RFP and the name of the RFP. So upon selecting what we want affected and hitting apply, we can now see that in the Save As section, we have a new name that includes the renamed string that we've applied. The same concept applies by stating where do we want to save as, or where do we want our copied seat structure to be applied, and using that same structure, the structure that we have inside of our system, we can then store our new or our copied seat template, or a new copy from a template. We can store it inside of the seat proposal folder. So upon selecting that option, we can see that our new folders, the assigned folder has then been updated with the geometry that will be copied. So let's jump into CATIA V5 now, and let's take a look. So we're going to step ahead here where we've already started within CATIA V5, where we're connected through the 3DExperience, where if we want right now, if we were to do a file open, we can see that exact same workspace structure with, for example, the ISD seat project, where our results are going to be stored to the seat proposal folder. And we can also see that same templates folder that contained the data that we had also made a copy of our seat structure from. In the middle here, we have our feasibility study assembly that will contain the OEM data that we require as part of our feasibility study, as well as a copy of the seat that we just made a copy of from our electric seat template. So right now, what we can simply do is we can copy our seat template data into the feasibility study, and we can perform that same operation on the OEM supplied data, where we can selectively go through and decide which pieces of geometry do we want to capture as part of the feasibility study, and do once again a copy and paste and capture that same information. So we're going to activate our seat or our feasibility study assembly and do a little bit of geometry manipulation just to start the evaluation of the feasibility study. So we're going to reposition our copied seat assembly and paste it into location for this specific study. So if we hide some of the geometry, we can now notice that if we zoom in, the seat trim outline which we can see in black and gray, is also interfering with our seat assembly. So what we need to do, the next step would be to make a design change to our seat assembly to then fit within the OEM requirements. So we're going to skip on the geometry modification step as part of this demonstration due to the time restrictions, and we're going to move on. But one last thing I'd just like to illustrate is that once we've completed our design changes, we have the ability to then save our data, save our feasibility study back into the platform, where we can simply select the geometry that's affected, browse to the location. So we want to move into our seat project and then save the data to the seat proposal folder. So going back to the capabilities review, just to sum things up, what we've quickly done here is we've basically developed and adapted our proposal in a very short time frame, where we've ensured carryover of all the knowledge from previous projects, hence capturing and reusing our existing design templates or design IP to then build that into our new the new proposal or feasibility study. So essentially, we're capitalizing and reusing global design for better quality and easy upfront design alternatives and validation. So moving on to the fourth day of the audit, we meet up with the sourcing manager for the sourcing and standardization review. As the auditor, the question that we have is, for some components, we have had issues in the past with the quality of the supplier delivery. Would you be able to propose new ones? So as the sourcing manager, my response is standardization is a key element for processes, but also for sourcing too. We keep track and we score suppliers for each project in order to reuse the best components for new projects. Our goal is to gain efficiency and cost reduction by capitalizing on part reuse. So our current objective is to reduce the number of seat slider models being used and set a new master for the designers to select in the future. So let's start by finding all the parts provided by some common suppliers, including Valfy and also Zhang. So as we filter the results by suppliers, we can see that the overall number of parts supplied by these individual suppliers is smaller than the overall result that we saw earlier. And we can see here from the results that there's a number of different seat sliders provided by all three suppliers. To get a better idea as to maybe the potential for some standardization, if we group our results, we now see that there's 42 groups out of 70 items in total. So this gives us a good indication there's a chance for us to standardize on a job. So we use the One Part app to automate our standardization to improve on our part reuse. And we're going to do this by creating a deduplication universe. So essentially what we're going to do is we're going to create a universe that looks for all the parts in the database or on our platform and group them together to look for potential duplicates. And we're going to create one called Seat Sliders Deduplication. Essentially, we're going to use this to set a new master. When defining our scope, we can select all the parts that are available to us as part of our deduplication search. And we also have the ability to define some criteria, such as looking for common names, part numbers, revisions, and materials. Once we've defined all of our criteria, we run the analysis. Upon selecting on our deduplication universe, any cell that shows up in red represents a cell with potential master model and also duplicate models. By selecting on the cell, we can now see that there's 29 different potential parts that can be defined as the master for our seat sliders, and the current master is flagged with an orange circle on the top right-hand side or an orange ribbon. To define or to compare, we just select on the models that are of interest. In this particular case, we'll use cost, for example, as a factor to look at. And with the comparison results, we can now take a look at and compare, for example, name, family, type, and as well as cost and supplier. Knowing that Valfy is our preferred supplier, right off the bat, we're going to use the Valfy model as our new master, as it provides the best quality based on our results. As an added bonus, we also notice that the Valfy model is cheaper than the previous master. Now, although a bit more expensive than a couple other models provided by Zhang, being that Valfy is our preferred supplier, this is now going to be set as our new master. So upon hitting publish, we're essentially standardizing the results to the enterprise, which will now then be used to assist designers to choose from the best results for seat sliders in the future. So let's practice a navigation test to see if we can now quickly access the preferred seat slider. We'll once again use the power of the 6W tags to search for the objects of interest. Rather than searching by supplier, what we can also do now as a quick shortcut is using the one part reduced status. Upon selecting master, we then will notice that there's far fewer models, only 3 models that appear, including the seat slider, which is now defined as the master model. As you can see, automated standardization reduces the number of frequently used parts, thus improving the efficiency from a design perspective where duplicate parts are no longer being created. This also saves time on the duplication efforts of qualifying those same duplicate parts. With both the design and sourcing organizations on the same page, the supply chain organization now have both a visual reference to what is being ordered, and they also have the ability to negotiate better rates for a larger single order of a single master part. The next step of the audit involves meeting with the product manager to review the global capabilities assessment. So as the OEM auditor, our question that we have is, what is your average age of time of issue closing as well as project delay impacts? As a product manager, our response is all of our business information is tracked dynamically and in real time once entered into the platform. All the issues raised for my projects are tracked closely as they can introduce risk on the product delivery or quality. So let's have a look at all the issues, their status, and their closing duration. On the platform, we use the Issue Intelligence app to gain instant project status and to query issues. The overview provides us with a number of different graphs, including time of issues by status. These are interactive graphs, and in this particular case, we can see the time period from the detection to the action of the issues. These graphs are also interactive, where you can also toggle what information is relative to what you want to look at. The project dashboard also illustrates financial information for ongoing projects. So the information displayed, for example, includes project margins and budgets, where once again, it's interactive, where we can display both the margins, or if we want, we can toggle to display the budgets for each one of our different projects. Further on down, we can even see a cost breakdown for each project, where we can then take a look at the engineering costs or manufacturing costs for each of the different projects that we have access to or that we're tracking. So towards the bottom, we can see a list of issues, for example, by project or by status over the project or even the age over the project. So let's get a look at the issues related to the ISD seat project, and we're going to review any issues that have been flagged as defects. So once again, going to the bottom, we can take a look at the issues by project. By selecting on the graph, we can then filter issues specific to the project. In our case, we also want to flag and review the issues that are flagged as defects. So by picking on defect, we now can see that we have one issue that is flagged as a defect for our ISDC project. And to get more information, we can then view the details of that specific issue, which is familiar as we looked at this issue early on in the audit process. By picking on the issue, we can continue to drill down through the rich information that's available through the entire platform to see what are we looking at the issue, what's the priority, has it been escalated? In this case, we know it has been escalated, and we can even see the actual timeline of the issue from the time it's been created to assigned, activated, or even reviewed. To drill down further, we can also then determine and find what other information is related to this issue, and going back into a familiar interface, we can see what this issue was reported against and how it was resolved, as well as any additional descriptions. For example, we know that we have an FMEA process in place for this specific issue. So what we just saw here is essentially the platform as a business framework helps us drive continuous and sustainable growth as we use the dashboards to monitor product development activities, identify risks, and even look at any possible deviations up front. So this gives us a better decision-making process with ease of access to rich, detailed information that's, again, linked and fully traceable. So the final step of the audit involves another meeting with the product designer to understand how product enhancements are managed. So question from the OEM auditor to the designer is, how do you handle all design changes we send to you? As a product designer, my response is that as part of a project, I receive a notification from a data coordinator that we need to modify, in this particular case, the seat to include some OEM updates. So as we can see here, we're in the CATIA V6 integrated environment. We are connected directly to our platform. And what we're looking at here is, as a result of a quick interference analysis, we're going to take a look at any type of contact between the OEM models and the seat structure. So what we can see here right off the bat is that one of the components of the seat slider is in yellow is interfering with the one of the floor panels. And to get a better idea, we can change the transparency of the rest of the context material to get a rough idea as to what is the surrounding geometry. So we quickly can see that from the seat rail that there's some clash. And there's a couple other clashes that are taking place as well that we can now see as we navigate through the clash analysis, that the motor assembly is also interfering with the floor panel. And a last piece of clash analysis, again, having a hard time looking. So I'll just scroll through and just remove change the transparency setting to see that, again, another piece of the seat slider mechanism for our chair assembly is interfering with the updated floor plan that we have displayed in our overall feasibility study. So turning the interference analysis off, we can now take a look at all the geometry that's displayed. So we understand that we have to make a design change as a result of the updated information that we received from the OEM and also the notification and the analysis. So our next step is to initiate a change request. So the powerful thing that we have here is being part of the platform as opposed to a separate application is we have the ability to create a change action right on the fly. So our change action here is going to be change, we'll give it a title, track mechanism. And we can use the same as our description here. We can define the severity and then also the date that this is supposed to be completed by and select OK. So within the same platform, our change action is created on the fly where we can see the basic properties of the action. And at this point in time, we're going to just quickly assign a reviewer for the specific change action. So again, we can just do a search in the platform. I'm going to pick this user as the reviewer. The next step is going to be to define what are the proposed changes. So what do we want to change for this specific example? So I'm just going to select add, and I'm going to go back to, I can either search through the database or I can go back directly to my 3D model, and I can pick the entire seat assembly as what I want to change. Rather than changing the current revision, I can actually change the new revision of the model. And why? I can say to resolve, I just need to give a reason. So to resolve interference. And that's pretty much it. So upon hitting realize changes, we can then see what's actually involved or what's involved with the session. But one thing we may want to do first is just change the life cycle state from being in preparation to actually state that that we're actually changing the state to in work. So the change action was promoted real quick, just a click of the button. Our realize changes will tell us the models that are impacted, and that after the revision, they'll go from A1 to B1. So the next step is, without really changing the interface, we're just changing tabs, we can now go through our design change. So within the assembly workbench, or the assembly environment, or app, I guess I should say, we can then go to and take a look at different functions that are available to us, including browsing a catalog for a different track mechanism that we can use. So there's a few different track mechanisms available to us, and as part of the automation and modularization capabilities, we also can use a little bit of logic to program our search. So one of the things that we know is that we want to go to an electric track, or we want to maintain an electric track. So one of the questions, what is the rail type? So the operator would be rail type is equal to, and the value from the drop-down menu is electric. And the next step is, because we know that the existing track mechanism with one motor in it is causing interference, let's go to a low profile track that has 2 electric motors or more. So we can go to the operator equal to and greater than. There we go, sorry. And enter in a value, we have 1 or 2 available to us. So we'll now update our results so that we can see we only have 1 track mechanism to select from. Makes it a lot easier for the selection process, just entering a little bit of logic. So from this point forward, we're just going to quickly replace the existing track mechanism with the new track mechanism. So right from the tree, I can go through, I can select my track mechanism to be replaced, and the change is now complete. We can even see the change is updated with the track mechanism in place, and the change is now complete. If we want, we can then go through as part of the rest of the process, complete the changes, set to approval. There's a review that needs to be completed, and that would then close out this action. So quickly, we saw an example of where we can use modularization to increase our product diversity. So again, bring new innovation or potential for new innovation to our products. And we also saw that change actions can be really easy to initiate and to manage. One of the other things that we also saw is the embedded capabilities of the space analysis tools to quickly predict manufacturability, such as interferences, made it really easy to detect a problem. It was really easy to implement a change action. And again, using the modularization, we had, in a matter of a couple of clicks, we're able to deploy and use a different model to solve the problem. So to close some things out, let's take a look at the takeaways. So as far as optimize and extend our product development process, we saw we have the ability to increase our product portfolio development planning, efficiency, and quality with the use of integrated requirements management, project management, design, and quality apps, which gives us the ability to leverage these capabilities as a method to turn around bids faster or increase with design reuse, provide better quality, or even just in general, increased collaboration throughout all the product development process. From the standpoint of ensuring our business health, we use real-time, and we illustrate how we use real-time program intelligence to prevent risk or anticipate deviations, to take proactive or informed corrective actions based on real-time data displayed in charts and tables for us to investigate and then pursue further and drill down through all that rich information that's available to us, and it's all linked together throughout that entire product development process. And as far as transforming, we saw it with the ability to transform our engineering capabilities by validating and optimizing our products up front. We had the ability to perform limit tests using CAD from any type of a system. We saw there's NX and SolidWorks data in it. And through the use of design modularization, we've got the ability through all these combined capabilities to transform a design and essentially get it and design it right the first time through all these front-end capable features that we have to us. So just to close things out, Bid to Win it's a lean and flexible and scalable production capable solution suited for everyone involved in the product development organization. So if you have any questions, feel free to feel free to submit them to the question and answer panel at this time, and we'd be happy to follow up with you. Feel free to reach out to me directly or contact your Inceptor account manager if you'd like to receive more information on how the solution or components of the solution can impact your business.